What is the Higgs boson? The Higgs boson, sometimes referred to as the God particle, is what gives particles and everything around us mass. But what is it, and why is it important for scientists? Today, we're going to attempt to provide a layman explanation and a bit of history regarding this enigmatic particle. A bit of history. Before we dive into what the Higgs boson is, we need to explore one of the fundamental questions in nature. What is stuff made of? When you look at a house, a majority will say that the house is made from either stone or wood. However, when you look closer, you find that even those substances are made up of smaller and smaller stuff. Eventually, you finally get down to atoms. Because atoms are so small, we believed for decades that they were the smallest things in nature and were the fundamental building blocks of everything in the universe. Eventually, scientists stumbled upon the much smaller electron, which led to the discovery of neutrons and protons, birth of the Higgs boson. Scientists and researchers wondered if it was possible that these particles could also be made up or from something more fundamental or smaller. It turns out that the electron isn't made of anything and cannot be split. However, scientists did find that the proton and neutron were indeed made up of something smaller, even tinier particles called quarks. Due to the effects of quantum mechanics, things act very strangely in the universe of the small, and quarks especially so. Right now, putting aside string theory for a moment, physicists believe quarks to be fundamental particles, that is, they cannot be broken down or divided into anything smaller. We explain this with something called the Standard Model. Unfortunately, the Standard Model doesn't explain why things have mass or weight. Because of this, Peter Higgs, a theoretical physicist, suggested that something else must be causing particles to have mass. His hypothesis, which consists of some complicated mathematics, suggests that another particle should exist that gives others mass, and thus the Higgs boson was born. How will we find it? We're looking for it by smashing particles against one another incredibly hard. In the debris that they leave behind, we should be able to see evidence of the Higgs boson. We do this at huge particle colliders such as the LHC, which is a whopping 17 miles in circumference. The detector at the LHC. This process is not easy because it's incredibly messy when we smash things together. We use protons for the collisions because anything bigger causes too much debris, while anything smaller doesn't cause enough debris. One of the challenges researchers at these particle colliders face is that they don't actually know how big the Higgs boson is. This is important because it makes it harder to know exactly where to look. Peter Higgs' original guess says that it could be extremely big. More recently, using refined math and experimental data, the Higgs boson is expected to be smaller than that, but still very big. If we find it in this very big range, then scientists also expect to see evidence of supersymmetry, which is extremely important. But we'll get to that in a future article. Finding the Higgs boson isn't the end-all for particle physicists, it's only the first step. There is still a lot of important questions left regarding particle physics and quantum mechanics. Finding the Higgs is only the beginning. The next step will be answering what it means and what the repercussions of finding it in a certain energy range are. A layman explanation of how the Higgs works. The Higgs field, or the Higgs boson, using an analogy, can be thought of as a magnet. Most materials, in this case, other particles, need an outside magnetic field to become magnetic to gain mass or weight. The Higgs boson is like a permanent magnet in that it causes its own magnetism mass and will induce it in other particles or make them magnetic. Without the Higgs, physicists will have to go back to the drawing board, and it will upend decades of research and mathematical models. Update July 4, 2012. CERN, the organization responsible for the LHC, has recently announced they found the Higgs boson at 125.3 GeV/c with sigma 5 certainty. Sigma 5 is a measurement scientists use to describe how accurate their findings are, and it means that the data is 99.999% accurate. Now that the particle has been found, scientists will attempt to ascertain its properties, and then turn their attention to finding out why individual particles have the masses that they do.
Thanks for watching. Please subscribe Space Facts channel to see more awesome videos.